Hello, welcome to my video on solving equations or making x a subject. So today we are just going to go through the basics and see what kind of techniques or what kind of skills we need in order to find x. So just to start off before we do anything, if you don't know, making x a subject simply means finding the roots of an equation. If you don't know what that means, it basically just means x by itself equals to something. That could be anything. That could be a numerical value, that could be an algebraic value, but basically all it means is you want one side, we'll call that the left-hand side, x equals to something on the right-hand side, because making x the subject by itself is what we're trying to do. So that's simply all making x a subject means, or solving equations. Now x can be replaced with any value. It could be x, could be y, could be the Greek letter lambda, could be epsilon, could be z or z, could be anything you want. But for the time being, just to keep things simple, we'll keep it x, and x, okay? So you can replace these. It could be 4y plus 2 equals 10. That would just basically mean making y the subject instead of x, but it's all the same thing, all the same concepts used. So now that's done, let's get started. So we'll do question one first, obviously, going upward order. So here, what do we want to do first? We want to get x by itself, or the 4x by itself. So we have a plus 2 here. So to eliminate the plus 2, we use the opposite sign in order to get rid of it on one side, and it comes up on the other side. So we're basically subtracting 2 to both sides. So what you want to do is do minus 2, minus 2. You can think of it this way, or you could either think of it as this entire thing is being moved over here. But to move it over here, you have to look at the first sign in front of it. So always look to the left of the unit to see what sign it is, and do the opposite of that. So hence why here it's also minus 2. So you can think of it either way, both way works. So once we've done that, you get 4x, because that's unaffected, and then plus 2 and minus 2, so 2 minus 2 eliminates each other. So we get plus 0, basically. And then on the right hand side, we get 10 subtract 2, which equals 8. Let me write that a little bit better. 8. Okay, so now that we have the 2's eliminated, how will we get x from this to become x? Well, what this is saying here is saying 4 multiplied by x equals 8. So what you can do is, again, thinking of this concept here earlier, where we're subtracting from plus 2 and minus 2 to eliminate it from one side. How can we eliminate 4 from this side and put it over here? Well, 4 times x, the opposite of multiplication is division. So what we can do is divide both sides by 4. You can think of it either like this, or you could think it of 4x over 4 equals 8. Either way, it's exactly the same. I'll just make that the same color as everything else. There we go. Okay, so with both of these, we can see that 4 is eliminated by 4, because 4 divided by 4, or asking a question how many 4's go into 4, is simply 1. So we have 1x equals, same thing here, 1x equals, oh, forgot the 4 divided by 4 here, equals 1x, and then 1x equals, sorry. And then on the right hand side, we have 8 divided by 4. So how many 4's go into 8? Well, the answer to that is 2, because 4 times 2 equals 8. So 1x equals 2, 1x equals 2. So our final answer is x equals 2. And that is the answer. So usually we don't put 1x, we just consider that as x because 1 times x is x, so that's why it's just an x here. There's not really any other explanation for that other than it just looks nicer this way. So now you've got your root, you're wondering how can I check if this is correct? So since you have your x variable here, you've defined x equaling to 2. In order to check if this is correct, you just basically substitute this back into the equation. So our earlier equation was 4x plus 2 equals 10. So as you can see, there's the x over here and the x over here. Those two x's mean the exact same thing. So all you need to do is write 4 times 2, remembering to use your BIDMAS rules, and then plus 2 equals something. So we know that this becomes 4 times 2 because this is the same as 4 times x, and we know x is equal to 2, which is why you get 4 times 2 down here. So 4 times 2 is 8, and then you have your plus 2 that you need to remember. So you have your 8 plus 2, and 8 plus 2 obviously equals 10. So you can officially verify that this is correct. Now for the second question. So here we have something different. We have a nonlinear equation, also known as a quadratic, and we know it's a quadratic because there's a squared. It's an x squared over here. That's how we know it's a quadratic. If it was a cubic, it would be x cubed plus something, da-di-da-di-da, and then a quartic, x to the 4, da-di-da-di-da. So, we are solving a quadratic here instead of a linear equation here. This is considered, put it in a different color, this is considered linear equation, put EQ for short, and non-linear is this. It's not something you particularly need to know from the top of my head that I remember, but it's just nice to know what you're solving. So, I'll put quadratic as well. So, since we're dealing with a quadratic, there are, there are 2 ways of solving this. So, the first way is a bit more tedious, just the way we will be solving or doing today. And if you're watching the full version, then we will be doing both versions, unfortunately. So you have option A, which is to factorize by hand, and B is using something called the quadratic formula. Now, this sounds scary, but honestly, it is just one formula that you need to remember. It only works for quadratic formulas. It doesn't work for cubics or quartics like x to the power 3. It only works for equations that have their highest x to the power of 2. So we will be dealing this with the full version. For the time being, we'll just have this method, which is factorized by hand. So if you're factorizing by hand, there is a method called FOIL. I'm not sure if you have heard of it yet, but it basically means just to factorize it so that like terms are together, and then when you expand it out, you'll see that it's the same. So this can be fairly difficult to do at first, but once you get the gist of it, you understand kind of what it wants. So here we have, I'll just cross it out for now. So here we have x squared plus 2x plus 1 equals 0. Now, how do you get x squared if there are double brackets like this? I'm going to assume you know how to expand brackets before you factorize, because factorizing is not significantly harder, but slightly harder than expanding brackets. So I'm going to assume you know how to expand brackets, where you have, let's say, x plus a, so a would be a number, and x plus b, so b would also be another number. So expanding would obviously be like this, getting this variable multiplied by this variable, and then the x multiplied by the b, the a multiplied by the right hand x, the a multiplied by the b, and that's how you expand brackets. So I'm going to assume you know how to do that. So I've already given the answer away, but in order to get x squared using double brackets, we have x here, close the brackets because we're going to have some filler numbers here in order to get these bits. Open another bracket, have x here, close the brackets, obviously have some filler bits here, and then equal to 0. You've got to really remember that this is the key bit, because in the future this could be equal to 10, could be equal to 50, could be equal to anything. So you've got to remember this here. Okay, so now we know we've got our x squared. That can be basically eliminated. We can just take that out of the equation. We don't have to think about it anymore because x times x gives us x squared. So what I like to do for easier terms that are more visually easy to see is see what two values can be multiplied to give you this number and added together to give you this number. So what I mean by that is, let's say we have x plus a and x plus b again, a being a given value and b being a given value. So what I mean by what I just said is, I'll use this color. A multiplied by b gives you 1, and a given value again, plus b, another given value, equals 2. Now what's handy about this rule is, if you can visually see this rule happening, is that if we do a multiplied by b, so we've got the x squared already, so I'll just put the x squared down here. And then we've got the multiplied by ab, and then we got a multiplied by x, so we have a plus ax, and then a b multiplied by x, or x multiplied by b over here, so we have plus bx equals 0. So this seems a bit complicated, but I'm just going through the algebraic method before we actually plot in numbers, because it'll be so much easier in the long run. So here we have a like term, we have x, so we can factorize this out. So we have x squared plus, we have the x because they're the like terms of these bits, and then you have a plus b because we just factorized out x from here, then plus ab, plus ab. So all I've done here is I've factorized this bit to give us this. This is exactly the same. You can check for yourself by doing the working out. By expand this, you get this. And then I've also moved this over here, because what we can see from here is that this formula over here looks very similar to this formula or equation over here. Now, this is no coincidence. This is because they are similar, because of this general golden rule over here. So what we can do here is C, two values, A and B, which satisfy this and this. So let's substitute some values in. So let's make A, I don't know, equal 1. And let's make B equal 0. So, does these two values satisfy these two rules? Well, let's see. So A times B simply means 1 times 0. Does this equal 1? The answer is no. 1 times nothing is always nothing. 1 times 0 is always 0. That is non-negotiable. That is just a mathematical rule. 1 times 0, 2 times 0, 3 bajillion times 0 will always equal 0. So therefore, we can tell that A equals 1 and B equals 0 is not a valid combination. This combination of numbers will not work for this formula. So let's try another set of values. Let's keep A as 1 and let's make B equal 1 also. So what's A times B? Well, A times B is just 1 times 1 and 1 times 1 equals 1. So the first rule is correct. It's fulfilled it. Now let's do the second one, A plus B. So A plus B is just 1 plus 1, and that equals 2, which fulfills this answer over here. Because remembering that we got A times B equals 1 from the equation, and A plus B also equals 2 from the equation, because these are known as the coefficients of the equation. Okay, so now we've got that all cleared up. So we know that A equals 1 and B equals 1. So we have our final answer here, which is answer equals, from here, this is what we were trying to do initially. We have x plus 1, right? Because x plus A, and we've found that A equals 1. And we have x plus B over here. And we found that B equals 1 also. So it'll be x plus 1. And obviously remembering equals to 0. Now, this is not the final answer. This is the answer of factorization. So what we need to do is set both of these, because now we have two separate equations, pretty much, and set them equal to 0, because you have your left-hand side and your right-hand side, and your two equations. So we can now come off and do x plus 1 equals 0, and x plus 1 equal 0. Now, we get x minus 1 on both sides, minus 1 on both sides. I'm pretty sure you already got that now. And then you've got x equals -1 and x equals -1. So in this scenario, we don't have two roots or two different roots. We still have these two roots. These are considered two separate roots because A was 1 and B was 1, which is why we got the same root. But these would be considered two separate roots, but they're the same value. So you'll learn in the future that there's something called a discriminant, which will determine how many real roots that you'll have. However, that's for another day, because sometimes you might see, I don't know, x equals 3 and x equals -4, depending on the equation. But for this example, we got x equals -1, x equals -1. So your final answer is x equals -1, and that is correct.